Hey, and welcome to this lesson video. Now, video is not required for your grade. However, some students asked me to make a video of what we went over in class, so here it is. This is going to be talking about applications of property of exponents, in particular adding, subtracting, and multiplying expressions using our exponent rules. So, here are a few screenshots. I won't stay long on these screens. Maybe. Here we go, of just how to add and subtract fractions. And the biggest thing that you should note, well, sorry, I labeled it subtracting, but then I actually added across all my fractions. But regardless, the process is the same. Here's what you need to know. You need the same denominator to add or subtract fractions. So that's the key. If you need to freeze the video here to look at these examples, feel free to. Okay, now multiplying I'm not too worried about because we've been doing a lot of these already. You just go across the top and across the bottom of your fractions. However, division is new for us. And you'll notice I wrote a phrase, keep, change, flip. That's really the key to dividing. Now let's notice how this worked. If I look at my first initial problem, compared to my first step, keep represents the 2/5. I kept the 2/5. Change, I changed division to multiplication. Flip, I took the second fraction and I flipped it, okay? I made the 10 on top and the 1 on the bottom. So keep the first, change to multiplication, flip the second fraction. And then it turns into multiplication like above, like we've been doing a lot already, okay? So let's look at some examples with our property of exponents. Now I'm going to go through these kind of quick because we've been doing these 2 or 3 days now. Work within each parenthesis, moving what needs to move. So just the b and the c, because they have negative exponents, need to move down. So I have negative 5a on top. I have a b positive 1c squared on the bottom. Now the second fraction, whenever you have a power of 0, you can scribble it out, act like it wasn't there. I do have this negative that needs to go to the bottom though. So 3, come on computer, a squared over a b cubed. Now this is division, so remember, keep, change, flip. Okay, keep the first fraction, negative 5a over b1c squared. Change it to multiplication, flip the second guy. So b3 on top, 3a squared on the bottom. And now I'm just going to multiply straight across. So across, nothing multiplies here, so we're just going to basically rewrite negative 5a b cubed. On the bottom, everything's different down there too. So I'm just going to rewrite it, but I'm going to put it in alphabetical order. So a squared, b to the first, c squared. Okay. Now don't stop here. All of our rules for exponents still apply. So as an answer, this is not completely simplified. So, I should do some reducing. Okay. Let me change back to my pen. Negative 5 and 3, those are not going to reduce, so I'm stuck with them. However, I have an a on top and 2 a's on the bottom. So with some canceling, I would have a single a left on top. Now let's talk about the b's. I have 3 on top and 1 on the bottom. Well, with some canceling, you'll have 2 left on top, none on the bottom, and then I would have my c squared. Okay, so there's division. Keep, change, flip was the key to this one. Multiplying, we've done a lot of these already. I'll go ahead and do this one real quick. All right, so in the first parenthesis, move your negatives. Okay. The second parenthesis, there's nothing wrong with him, so just rewrite him, but put a 1 underneath, and then multiply across the top and bottom. Okay, so we would have 5 times 2 would give me a 10. There's only one x, so keep that. Y to the 4th times a y squared. Add those exponents to get y to the 6th. On the bottom, I'm just going to have an x cubed. Now, like we just talked about, don't stop here. You have a double variable. Okay, we got x that's repeated. So 1x on top, 3 on the bottom. So when I cancel one of them, I will have 2 left on the bottom. So there would be my simplified answer. Now here's where the fun part begins. Woohoo! Adding and subtracting, okay? Now, like we said, to add, I need the same denominator. So let's see what happens after I, move anything denominator. There we go. Like the first term here, 4 over x, there's nothing I can do with that. However, the second term, x should go to the bottom. So I've got my first term. The second term, I fix it. Now, are my denominators the same? Hopefully you're saying yes, because they both have an x. So the math really only happens on the top here. 4 plus 6 is 10. Once your denominators are the same, it just stays that. And 10 over x would be my final answer. Now let's look at this guy. Again, that first term, there's nothing I can do. I'm subtracting. Let's see, in the second term, b to the 0, scribble it out. Move a to the top. So let's see, I would have 3a on top. Nothing on the bottom, so fill it with a 1. Now again, I need the same denominator. Whoops. One too many squiggles on my m. So let's try this again. I need the same denominator to subtract these guys. There we go. Okay, since I need the same denominator, we kind of have a problem. We're in a pickle here. This first fraction has a 7, but the second fraction has a 1 underneath. So how can I get them both to be the same? Well, couldn't I multiply 1 by a 7, and then they would both have a 7? But to do that, I have to multiply the top by the same thing. So what's going to happen? We have 4a over 7 minus, now do 3 times 7 to get 21a. On the bottom, 1 times 7, 7. Now they're the same. Now on the top, remember like terms in Algebra 1. So let me kind of deviate off to the side real quick. Think back to Algebra 1 and let's talk about some things real quick. 3x plus 10, would I be allowed to add them? No, they're not like terms. What about 3x plus 10y? Could I add those in any way? Again, we would say no. What about 3x plus 10x? Whoops. Now those, because they're the same letters, I can add. So I can, let's say, what it would equal. 3x plus 10x would equal 13x. Notice how the variable did not change, just the numbers in front, 3 and 10. Now another question, 3x squared plus 10x. Can I add those? They have the same letter, but do the letters have the same powers? We have an x squared and an x. No, the powers are different, so we need to say we cannot combine those. Now, what if I had 3x squared y plus 10x squared y? Are they like terms? They have the same letters with the same powers, so I can add them to get 13x squared y. Okay, so I did this off to the side because we need to be careful. Don't mix up property of exponents with the rules for combining like terms, okay? Because when we go back to the left here, 4a over 7 minus 21a over 7, remember we talked about the math really happens on the top once you get your denominators the same. So 4a minus 21a, can I actually subtract those? Think about what we did over here in the red. Yes, I can. I would get negative 17a, and my denominator just stays the same. So that would be my final answer. Okay, so make sure you're being careful and keeping track. Now let's do another one real quick. What would need to move? The z needs to move on the first one, so 8xy, 3z on the bottom. Anything need to move on the second one? No. Okay? So, are the denominators the same? Ooh, 3z and x to the z, xz. No, they're different. They both have a z, but this guy has a 3 and this guy has an x. Well, what if I multiply the first one by an x? Okay, and what if I multiply the second one by a 3? Then they would all have the same on the bottom, 3xz. Okay, so let's work on cleaning up this top. We would have 8, there's an x and another x, so x squared y. And I'm just going to, on the bottom, I'm going to write them in alphabetical order, 3xz. Okay. On the top of the second one, I can multiply 3 and 5 and get 15, y squared. And again, I'm just going to rearrange it, 3xz. So that way they're the same. Now, thinking about what we talked about on the last slide over on the side, that little side note we did, the math really happens on the top. We're adding, but can I add 8x squared y with 15y squared? Are they like terms? No, they are different. So our final answer, here's what we do. We keep 3xz on the bottom, but we have 8x squared y plus 15y squared. And that would be your simplified answer. Okay, so that concludes our examples on this extension of property of exponents, adding, subtracting, multiplying, and dividing fractions. This will help you again with what we did in class. I am grading 1 through 6 on that yellow worksheet, or maybe it's white, depending on your class period. I am grading 1 through 6 for correctness, so please take your time, rewatch this video if you need to, but keep learning and have fun, guys.